Hello, I'm Estella, a rising ninth grader at Redshire School. Agriculture is at the heart of everything we have in life, from our food, clothes, to the medicine that keeps us healthy. For 3 generations, my family has operated agricultural-based enterprises that deal with chemicals, pesticides, and biotechnology. I've grown up understanding that agriculture isn't just a business, it's a relationship. Inspired by my grandfather's commitment to the land and to the people who cultivated it, I wanted to find a way to support sustained practices and honor the hard work of the farmers. I wanted to devise a way to help farmers find cost-effective and environmentally friendly solutions to the issues they were facing. I had the opportunity to ask some employees about those challenges when I was assigned a school innovation project. One subject came up repeatedly: land fertilization. Excessive fertilization causes the soil to harden, while too little fertilization leads to nutrition deficiencies. When soil is improperly fertilized, it can lead to an imbalance in the composition, which is detrimental to the crops. I decided I wanted to develop a way to achieve precision fertilization. Having an interest in robotics, mainly quadcopters and helicopters, I began designing a product that could test the soil and then use the scientific data and technology to apply the right type and amount of fertilizer to the correct part of the land at the right time. Factors such as nutrition levels, pH, and moisture all need to be accounted for, as did the needs of the specific crops and any environmental factors such as weather or terrain. First, the robot will need a mind. And we need to be able to interpret soil testing data and calculate the appropriate amount of fertilizer to add for optimal soil composition. I assigned this task to an Arduino chip, which makes judgments based on data analysis and processing. This is what would ultimately allow us to automate the process. Next, the robot would need legs to move easily through different terrains. I created a 4-wheeled structure with gripped rubber tires, making it adaptable to the uneven landscapes. The robot would also need hands to accomplish everything from soil testing to fertilization. I created a motorized sliding screw that could automatically insert the soil tester and use to relay the data to the pesticide tank, which would pump out the amount of spray or fertilizer needed. Using what I know about robotics, programming, and AI, I was able to not only build a robot, but also implement its usage. Employees mentioned that receiving data remotely and making decisions based on feedback would be an essential part of achieving agricultural automation and smart farming. With the robot built and aided by a teacher, I designed the system's remote terminal page and data transmission. And after 4 months of hard work, my prototype was finished. The current version of the robot can last for 10 hours, run for kilometers in steep fields, and complete fertilization options within 10 hectares. Farmers 5 to 10 kilometers away can accurately observe the fertilization from the remote control panel, making the system autonomous while allowing farmers to monitor the machine and ensure it works correctly. When experienced workers tested this system, they were impressed with its capabilities. I have also brought it to some science competitions and received positive feedbacks from agricultural professionals. I'd like to continue to explore this solution and see how I can relate it to my interest in aerial vehicles.